Alright, so again, when we're predicting the single replacement reactions product, we're going to look at whether something is more active or not by looking at the activity series. Activity series will be provided to you, and it's this chart. As you go up, you're going to increase in activity, right? Which means the one at the top will not get replaced by the things at the bottom. Make sense? Okay, so remember the metal, which is usually positive, also known as cation, can only replace either metal, another positive ion, or hydrogen, which is also positive. So essentially positive will only replace other positive, never negative. So what that means is that if you have a metal, it will only replace metal or hydrogen, because hydrogen is positive even though it's non-metal, right? Okay, so remember we saw this other chart. Let's go to the next slide. That in this case, you have a reaction, right? Right? So A ends up replacing B. So that means, what can you say about A? It's a higher in reactivity than what? B. So what that means physically, where is A compared to B? It's above. No. Yeah, yes it is. A is above B on the reactivity chart. Second possibility, you don't see any reaction happening, so what can we say about A and B?
B is higher on the activity.
B is higher, and this is lower, and that's what we're going to see. B is going to be up here, so A is going to be down here, so A cannot replace B. And remember, A and B are replacing each other because they're both positive, or both metals. And that's what we're going to see, higher, lower, and higher. Good. So now we're back to this. We said that this reaction will or will not occur. It will occur because Mg is higher or lower? Higher in the activity series than Al. Now, what did you guys get for number 2? No reaction. I agree. Because why? Because iron is higher up on the activity series than copper. So copper can't replace it. How about number 3? No. Why not?
Sodium is higher than lithium.
Exactly. So, wait, sodium is higher or lithium is higher? Lithium is the popular guy. He is already really reactive. Sodium can't take place of this guy. So reaction will not occur. Now, how about number 4? Who wants to help me out? Jasmine, go ahead. No, I'm talking about number 4. Zinc and silver? Sodium. Number 4? Oh, okay, I thought I used to use the sodium, I'm sorry. Okay, so is this going to happen or not? Yes. Why?
Because silver is
Because zinc is a higher up in the reactivity series than silver. So zinc will replace silver. Okay, think of it this way. And zinc is, we said, is higher, right? And silver is down here.
So if it's on the right, it's still not, it's
It has nothing, yeah, it doesn't matter. It does not matter. Zinc, if this is by itself, your question is this going to replace the other metal, right? So in this case, silver is lower than zinc, so zinc is going to replace it. Now, the question then is, am I going to have to balance this? And this is, by the way, yes? Yes, you're going to. So whenever this happens, you're going to write it all out. So remember, Mg is going to replace Al, and Al is going to go where Mg is. When you write it out, you get Al plus MgCl, 2, because Mg is positive 2, Cl is negative 1. Balance it out, you get 1, 2, 2, 1. Okay, how about, 3, 2, 2, 3, I'm sorry. 3, 2, 3, 3. One's completely balanced. Silver nitrate ends up being AgNO3 plus zinc. Now, you said it is going to happen, so you're going to end up putting zinc and nitrate together, right? Zinc is positive 2. Nitrate is -1, so when you crisscross it, you end up with zinc, NO3 with the parentheses, and then 2 at the bottom. Silver then becomes by itself without any charges.
So when it comes by silver,
So you're right, yeah, we need to balance it, Ronnie, right? So we end up doing 2 in front of silver, and then 2 in front of AgNO3. Am I balanced? Yeah, I'm balanced. Because look, I got 2 chunk of NO3 here, and NO3 too here has a subscript 2. So it tells you that this has a whole thing of NO3, both of them. Yes, ma'am?
I thought they swapped, so why is it on both sides? Why is the...
Because the conservation of matter says that whatever you have here has to be on the other side, right? So zinc is now taking the place of Ag, and Ag becomes by itself. So that's what you see. Ag is now by itself. Oh, you're asking, does it matter if you swap these? It doesn't matter. Hey guys, just a quick thing. If you wrote zinc NO3 2 first, and where Ag is right now, and you wrote Ag down here, it's fine. As long as both of them are on the right side of the arrow.
No, I mean like before you started doing this whole balancing thing, and when we just swapped, isn't it Ag plus Zn and NO3 too? That's just
AgNO3 is silver nitrate plus zinc.
okay. And so this is the revised version on the other side.
Yes.
So this is what gives us our whole thing.
Yeah.
When we do this.
Right. Are there any questions so far? Okay. Now, let's go to the back page because we're going to start talking about metals and acids. An acid is something that has hydrogen something something. It's on the second page. So if you have a metal that is above hydrogen on the activity series, it will replace the hydrogen. So hydrogen, I highlighted down here with the red. All these metals will replace hydrogen. So when I'm talking about any metal above hydrogen replacing or reacting with an acid, I'm saying that metal will replace hydrogen if it's above hydrogen. And that's what we've been talking about, where something is on top of something, it will replace it, right? So, I want you to go ahead and use your activity series to look at these metals and circle the one that's going to react with acid. In other words, circle the metal that's going to replace hydrogen.
C.
Okay? How about Cu? No. So it's not going to replace hydrogen, or it's not going to react with an acid. How about silver? I'm sorry, that's gold. Au is gold. No, but the lead will, right? And nickel will. Yeah, because nickel's above it. Alright, good. So you guys are understanding when it's talking about excuse me, reacting with an acid, it's saying, is it going to replace hydrogen? So let's actually do some practices. Joel, wake up. When you have metals replacing hydrogen, it looks a little bit different. It's still going to swap this way, but what do you notice about hydrogen? Because it's diatomic, when it becomes by itself, it has a 2 at the bottom right, because it's diatomic. Again, here, metal is for M. A to what we know is hydrogen. X is going to be the negative ion. I'm switching it. Because hydrogen is always going to be diatomic if it's by itself. Okay, you have the examples underneath you. Huh? No, not necessarily. If it's hydrogen by itself, it's going to be 2, remember? Okay, go ahead and do Zn and HCl. Ask yourself, is it going to react or not? And if it is, I want you to write a reaction. So we're on this now. It's on your paper, huh? is positive 2. ZnHCl, is it going to replace the hydrogen? Okay, so when it replaces the hydrogen, you end up with what?
CnCl2 plus H2.
Agreed, and? Good. Now we need to balance it, right? Just put a 2 in the front. You can do it the other way, that's 2. We do not work with chloride because chloride is a negative charge ion. We're looking at what two things in the reaction? Positive ones. So zinc and hydrogens are the ones that we're looking at. Okay, how about CuH2SO4?
No reaction.
No reaction because copper is not higher than hydrogen. So we say that this is not going to react. All right. I'm going to tell you right now that phosphoric acid is H3PO4. Now, is this reaction going to happen or not? Okay, it's going to happen. Now, what do you get when it's happening? Okay, you know it's going to have Ca and PO4 together, but look at the charges. Okay, remember, PO4 is -3 charge, Ca is +2. Crisscross it, you end up with, Anthony, you looking?
Yeah, I'm trying to write that.
Ca, 3 at the bottom, parentheses, PO4 with the 2 on the other side. Plus what? H2. Exactly. Okay. Because H is diatomic, and when it's by himself, he's going to be having 2 at the bottom.
Oh no, but, oh, okay, I see that.
Yeah. So let's go ahead and balance this on the other side. So here's a calcium and phosphoric acid. So calcium, H3PO4, and you said this is going to happen, so we're going to swap hydrogen and calcium, and I end up with H2 and Ca3PO4, 2. Now, does anyone have the coefficients ready? Yeah. Jamal. 3 in front of H2, 2 in front of phosphoric acid, 3 in front of calcium, and that's it? Am I balanced?
You need a 1 there, right?
No.
You got 3 calcium, you only got 1 calcium.
I got 3 calcium.
Oh, you only got 4 PO4, but you got
I got 2 PO4.
Oh.
You need 3 calcium.
I have 3 calcium.
Oh. I think you got smart.
This is balanced, right?
You need a 1 right there, right?
Yeah, it's 1.
Okay, but when I don't put no 1, you always
You
put
don't
no
have
1.
to. Right.
Yeah, you got right there.
Yeah, we talking
Is
about.
this good? Okay, so you have the rest of the class. There it is. Ah! Go back. There. So this is the finalized balance, and that's what we had. So the last page is exit ticket. Use your notes. I want you to fill it out, and I want you to hold on to it so we can grade it together. You're gonna just turn it into me at the end of the